Trigonometric reciprocals, cosecant, secant, and cotangent. A reciprocal is defined as a mathematical expression where the number 1 is divided by the function in question. For example, the reciprocal of sine x is 1 over sine x. A second definition is a mathematical function related to another such that the product is 1. So the product of sine x times 1 over sine x would give us 1. When discussing trigonometric functions in a pre-calculus class, it is common notation to use the Greek letter theta to denote the angle of measure. The reciprocal of sine is cosecant. If sine of theta is denoted as sine parentheses with the symbol for theta, then cosecant of theta is denoted as CSC parentheses with the symbol for theta. So recall from SOHCAHTOA that sine of theta is defined as the side opposite to theta over the hypotenuse, or simply opposite over hypotenuse. This means that cosecant of theta is the reciprocal of sine, so we flip it. Cosecant of theta is equal to hypotenuse over the opposite side to theta, or simply hypotenuse over opposite. So in example 1, we want to evaluate sine of theta and cosecant of theta. Recall that sine of theta is the side opposite theta over hypotenuse, so sine of theta is equal to 8 over 17. Since cosecant of theta is the reciprocal, we're going to flip that and take the hypotenuse and put it over the side opposite of theta, and we get cosecant of theta is equal to 17 over 8. So we can define the reciprocals of cosine and tangent very much the same way we did for sine. The reciprocal of cosine is secant. So if cosine of theta is cos parentheses, the symbol for theta, then secant of theta is sec parentheses, the symbol for theta. Likewise, the reciprocal of tangent is cotangent, and tangent of theta is tan parentheses theta. So cotangent of theta is COT parentheses theta. So we can define the reciprocal of cosine, much like we did for sine earlier. Recall from SOHCAHTOA that cosine is adjacent over hypotenuse. This means that secant will be the reciprocal of that. Secant is hypotenuse over adjacent. We can apply this definition to the example we saw earlier and say now, looking at this triangle, cosine of theta is adjacent over hypotenuse, which gives us 15 over 17, and secant of theta is hypotenuse over adjacent, which is 17 over 15. We will formalize the definition for the reciprocal of tangent as we did the other functions. From SOHCAHTOA, tangent is opposite over adjacent, therefore cotangent is adjacent over opposite. If we revisit our example once again, we can evaluate tangent of theta and cotangent of theta. Since tangent is opposite over adjacent, that will give us 8 over 15. And cotangent is the reciprocal, and that will be 15 over 8. So just a quick recap. The reciprocal of sine is cosecant, and we see that sine is opposite over hypotenuse, and cosecant is hypotenuse over opposite. The reciprocal of cosine is secant. Cosine is adjacent over hypotenuse, and secant is hypotenuse over adjacent. Because we're talking about reciprocals and how they flip, notice that sine starts with an S, and its reciprocal starts with a C. And notice that cosine starts with a C and its reciprocal starts with an S. Just playing off of that theme of flipping. We're not only flipping the definition, but we can flip the starting letter. And that will help us remember which function goes to which. So the reciprocal of sine, change the first letter to C and you say cosecant. The reciprocal of cosine, change the first letter to S and you get secant. Finally, tangent is cotangent. So that is the same function, just with a co in front. So you now know the 6 trigonometric functions.